So this video lesson is all about dividing decimals. We already looked at adding and subtracting decimals and multiplying decimals, so it's natural that the next area we go into is dividing decimals. And so real quick before we get into dividing with decimals themselves, I want to look back at integers. Now we have three ways that we can talk about division, or at least three symbols that we use to represent division. The most familiar probably to people is the division sign. That is a subtraction sign in red with a dot above it or below it, which in this case it looks in purple. So this is the division sign. We can also use that with what we call, or what is often called in lower grades, maybe a division house or something like that, to represent that whatever is being divided into is underneath this symbol, and whatever is dividing into it is on the outside to the left. And finally, the fraction bar, which also represents division. So let's real quick go through an example of dividing integers. We'll use this example of 575 divided by 25. So we first go to where we can divide 25 into the numbers starting from the left, or the digits starting from the left, and 25 can divide into 57. 25 times 2 is 50, and so that is the most times that we can have 25 divided into 57 without going over. 57 minus 50 is 7. Bring down the 5 and get 75. Now 25 times 3 is 75, and so we can end right there. We'll finish with this process down here. We are out of digits. We have a 0, so this is our quotient. 575 divided by 25 is 23. So now that we've gone through the idea of dividing integers and that quick review, let's look at an example where we might need to divide integers. So let's suppose you're a contractor looking at a lumber yard because you need to build perhaps a house, a barn, a shed, something like that. The point, though, is that you need 98 feet of lumber in order to complete this project that you have. But it's not that you just need 98 feet of lumber. You need 98 feet of lumber in segments of 3.5 feet per piece. So it's not just 98 feet. You can't have 12-foot pieces of lumber. You can't have 90-foot pieces of lumber. You can't have 2-foot pieces of lumber. You need each segment to be 3.5 feet long. So in order to figure out how many segments you need to buy, we'll split this 98 feet of lumber into segments of, or rather into even segments of 3.5 feet per piece. And to split a quantity into even sections, we use the operation of division. So now we're going to divide 3.5 into 98. So let's represent that in a few different ways. We have 98 divided by 3 5/10 on the left, which is a familiar format using the division sign. We also have 98 divided by 3.5 in the format that we often have with what might be known as the division house. So the first thing that I want to look at with this is the division itself. What would happen if we just tried to divide 3.5 into 98 without making any adjustments, any changes for the fact that they're a decimal? Perhaps we won't need to. So let's take a look at it. 98 divided by 3.5. Well, if we take 3.5, it's hard to tell how many times it goes into anything, but it looks a lot like 35. And we can put 35 into 98 twice. 35 times 2 is 70. 98 minus 70 is 28. Bring down a 0, put a decimal point, bring down a 0. And it looks like we should be able to divide this 3.35 rather into 288 times. In fact, we can. 8 times 35 is 280. And we get a 0. So we're done. So according to this division, we have 2.8 pieces of lumber will give us 98 feet. And that immediately should strike you as wrong, because the pieces of lumber that we have, 3.5 feet, if we only have just less than 3 of them, we're not going to have any more than 12 feet. We're going to have 10.5 feet of lumber with 3 full pieces, and right now we're looking at less than 3 full pieces. So we obviously need to do something different to this division problem to make it work. So I want to rewrite this division problem in terms of a fraction bar. Now remember that this fraction bar, the division sign that I'm going to circle in purple, And the strategy for long and short division underneath, as I said, could be called the house, all represent the exact same thing. But looking at it as a fraction bar, we can think about it a little bit different way. We aren't entirely satisfied with the 3.5 being in the denominator or being um, the divisor in this division problem. So we want to find a way of getting rid of it. Well, I know in a fraction, if I multiply and divide both numerator and denominator by the same number, we end up with an equivalent fraction, one whose division represents the same quotient or one that represents the same amount. So I want to get rid of one of these decimal points in the denominator. So I'm going to divide both numerator and denominator by 10. Remember, in the fraction rules, you can multiply and divide numerator and denominator by the same number and get the same fraction, or a fraction that represents the same amount. So if we do that, we end up with 980 divided by 35. Now, this division, 980 divided by 35, one that doesn't involve decimals and only integers, is one that we're familiar with and perhaps comfortable with too. Now we can go through and do this division exactly as it is. But we already more or less divided 35 into 980 before. And if you want to pause the video and go through that division to verify this for yourself, feel free. Otherwise, this division is going to turn out with 28 instead of 2.8. Now, if we look at this 28 and think, could that be the same answer that represents 98 divided by 3.5? Well, there's one way to find out. Let's multiply 28 by 3.5 and see what we get. Now, if we go through this entire division here, 8 times 5 is, or multiplication here, 8 times 5 is 40. 5 times 2 is 10 plus 4 is 140. Add the 0 for the 30, rather, again, not the 3. This is going to be a 30, or a 3 in this case we're representing because of place value. 3 times 8 is 24. 3 times 2 is 6, plus 2 is 8, and when we add this all up, we get 0, 8, 9, 1 decimal place. If you don't remember this part, go ahead back and look at the video lesson on multiplying decimals, and we do, in fact, get 98 feet of lumber. So 28 is the answer we're looking for. And so now if we remember that we multiplied by 10, 98 and 3.5, to get rid of that one decimal place, what does that suggest about when the divisor has a decimal point? I'm going to ask you to pause the video here and take a second to think and write down some thoughts you have. Write down at least 2 or 3 thoughts you have about what this suggests about when the divisor has a decimal point. What can we do to clear that decimal point, because we like to divide by integers, not necessarily by decimals. Well, in general, one of the things you should have noticed is that when we multiplied it by 10, we got rid of 1 decimal point. And if we extend that, when we multiply by 100, we'll get rid of 2 decimal points, 1,000, 3 decimal points, etc. And so what this means is that we can multiply our divisor by any power of 10 that we want to get rid of decimal points, as long as, like this fraction suggests, we do the same thing to the number being divided into. So let's take a look at that. An example, a larger example, 1500 is divided into 146.25. We don't like to divide with a decimal point there. We can't really divide by the decimal point there, so we have to move the decimal point to the right, so that 0.15 becomes 15. We actually do that by multiplying by 100. If we multiply by 100 in our divisor, we have to multiply by 100, not just in the 1500s, but also in 146 and 2500s, which will move the decimal point that same number of places also. So we have to do the same to both numbers that we're talking about. The decimal point now goes in the same place value as the new number being divided into. So this decimal point ends up right there, rather than between the 6 and the 2 like it was before. And it's very important, I know it's a little small here, but it's very important that we have to move both decimal points, not just one, otherwise we're creating a different division than the one we had before. 1500ths divided into 146.25 is very different than 146.25 divided by 15. So we need to move both decimal points. Now let's take this idea here, this one that we were talking about, and go through this division here to see what this answer really would be. 15 can't divide into 14, but it can go 9 times into 146, becomes 135. Take that through, you get 112. Now this can go 7 times because 15 times 7 is 105, becomes 75, and 15 times 5 is 75. So not only does 15 divide into 14,625, 975 times, but that original question we had, 146.25 divided by 15 hundredths, also has a quotient of 975. Now let's look at one more example to make sure we've got this. We have 7.5. It's being divided into 427.2. We need to move this decimal place in 7.5 one place, so that it becomes a 75. And we'll move the decimal point in 427.2 one place also, so that we keep our decimal point moving in balance. Now 75 goes into 427. If we think about it, 75 times 2 is 150. So 75 times 4 is 300. So 75 times 5 would be that answer that we're looking for. So 5 is the answer that we're looking for. 75 times 5 we said was 375. Divide that through. 7 minus 5 is 2. 2 minus 7 we can't do, so we borrow. 12 minus 7 is 5. And we are left with an answer, or left with 52 as remainder. Bring the 2 down. Now this is a little bit more difficult, so 75 times 6 then would be 450. 75 times 7 in that case would turn into 525, which is not quite what we want, so we only can go to 450, which is 75 times 6. 75 times 6 is 450. Subtract that out, and we end up with a 2, borrow 7. 72, so 720. Bring the 0 down that came on the other side of the decimal point because we need to continue. Now, how many 5 times does 75 go into 720? Well, it'll go in 9 times because 720 is very close to 750. 750, of course, being 75 times 10. So 75 times 9 then is 675. Subtract all of that out. Subtract all of that out, we end up with a 5. Now 11 minus 7 is 4. 450, we know that 75 times 6 is 450, so the answer we have here is 56 and 96 hundredths. So remember, when you move the decimal point in the divisor, you have to move it in both numbers by the same number of places. So there are 2 pages of practice problems. Take a look at both of these, see what you can do. Go ahead and pause the video, and then we'll look at the other 2 also. So let's start off with 574 and 75 hundredths. Let's write it inside the division process that we're familiar with. Now this one doesn't have any decimals inside the divisor. Now 11 goes into 57 5 times. 11 times 5 is 55. Will give us 2 as the difference. Goes into 24 twice. 22 to 27 also goes into 27 twice. Now we add the decimal point. Left with 5, and 5 goes into 55 5 times. So 52 and 25 hundredths is the answer that you're looking for here. And for the second one, again, let's write it as the division as we're familiar with doing it. Again, the number on the right-hand side of the division sign, the divisor, needs to go on the left here. Now we need to do something about this decimal point. We'll move this decimal point, and we'll move this decimal point, but we're not going to move it 3 places. Because if we move it 3 places, we've been moving it by an uneven amount. We can't just move it to the end of the number. We have to move it only 1 space. So there. Now, 19 does not go into 1. 19 does not go into 11. But 19 does go into 114. Now, we need to put that 0 above the 1 to represent that we checked that place value and can't actually divide into it. But 19, it turns out, times 6 is 114. 6 times 9 is 4. 6 times 1 is 6 plus 5 is 11. Divide that, or subtract that through, and we get 0. So the answer we're looking here is 9600ths. Final two, go ahead, pause the video, look at these remaining two problems, and see what you can do. So let's look at the one on the left. I'm going to move this up here. We've got 1596 hundredths divided by 0.16, 16 hundredths. Move the decimal point 2 places. So now this one is going to the end of the number. 16 does not divide into 15, rather it can divide into 150 9 times. 16 times 9, as we saw before, rather 19 times 6 is what we saw before, and it's a different one. 9 times 6 is 54, and 5 to 9 is 14. This becomes a 60. 16 goes into 63 times, and that becomes, let's get rid of this right here, and that becomes 48. 60 minus 48 is 12, 129. Now 16 goes into 44 9 times. We subtract 16, we get 128, which is going to be our answer for 16 times 8, 128. Difference of 1, 16, and 1. So, whoop, I made a mistake. Worth noting, I put the decimal point where the decimal point used to be, but should not be now. 16 hundredths, in fact, goes into 15,096 hundredths, 9,381 times. And finally, if we look at the last division here, 1379 and 24 hundredths divided by 4.1. Again, move the decimal place. Only one space. Put the decimal point up there so we know where it goes. 41 divides into 137 3 times. 41 times 3 is 123. Subtract through that and you get 14, becomes 149. Also divides in only 3 times. 123 becomes 262. 262 divides into 6 times. 6 times 1 is 6, and that is 24. Move that back up there. 262 divided by 246 gives you 16, and 41 times 4 is actually the same as 164. So the answer that we're looking for is 336 and 4/10. So again, just as a review, if you have a decimal point in your divisor, you can move it so that the divisor no longer has a decimal point, but you have to remember to do the same thing to all numbers involved in the division.